Welcome to today's webinar on managing water with confidence. We're going to be looking at culverts, ditches, and drainage in RoadEng. We are going to be starting right on time today because, well, like most of our webinars, we are going to be absolutely pushing the allotted time that we had. So in terms of content, today we are going to focus on those key drainage elements, as well as discuss how to work with our new hydrology tools that we released in version 11 to help you understand the impact of the road design and what it does to natural drainage patterns. We're going to include a bunch of demonstrations of workflows in software. So of course that's in our RoadEng software, highlighting practical approaches to how you can integrate those drainage elements. And we're also going to be leveraging our presentation a little bit more, in particular to talk through some of the impacts. So without further ado, let's get into it. Our kind of plan on a page for how we're going to spend the next 45 minutes together. First off, we sort of have two core objectives that we are going to be looking at when it comes to drainage. First of which is maintaining natural drainage patterns. And the second is minimizing the interception, accumulation, and redirection of water when it comes to our roads. So having those two sort of core objectives, the actual agenda for the webinar, we're going to be looking at the road impact that the road has on water and drainage. And we have a really great example that we're going to talk through that can help you understand what that impact actually looks like. Then we're going to go in the software and look at some tools that we have to help you visualize natural drainage, and then some workflows for the design of the drainage elements themselves. In terms of housekeeping, we are going to be tackling all the questions at the end. So if you have one and you're in the live webinar, you can type it at any time into that question section of the GoToWebinar panel. We'll tackle it at the end, likely in overtime. Beyond that, you are going to be muted. But yeah, please do engage with us through the question section. Okay, so the impact of water. Obviously, managing water is really, really important when it comes to the design of the road, and there are lots of hazards and a lot of negative outcomes that can result, whether that is erosion, increased sediment, debris flows, landslides, and if you're from the BC region, obviously we've seen a lot of those as a result of roads and water. So all of these negative hazards are situations that can happen when drainage is not addressed properly with the road design. The impact of water is not just, with hazards. It can also be much more subtle. And in this picture here, we really do love it. It shows the contrasting growth rates on either sides of the road. So water can have a tremendous impact. I mean, roads can have a tremendous impact in changing the water's flow. So whether that's through the accumulation or the redirection of water. Water can also have an impact to the road itself. And in this case, we've got potholes on the left, scouring on the right, where water and improper drainage is damaging the road itself. So water, again, really, really important topic. Drainage elements essential in proper road design. And with that, we're going to kind of pivot into this example where we're going to show you a steep terrain example, but a lot of the principles that we'll show you here really do hold true in flat design as well. And with that, I'm going to let Matt talk us through the next couple slides as we look at an example.
All righty. So as we can see here, we've pulled some LiDAR data, and as Aaron introduced, chosen a pretty steep, gnarly example, and but yeah, it's totally applicable. The concepts are totally flatter terrain, steep terrain. The nice thing about doing a presentation with it is it's really easy to visualize and see what's going on. So for this, we have this hillside that, well, has a lot of channels on it. And right now we've got the streams, if that hillside remains undisturbed, where they lie. Now, obviously, if we put a road across that, let's do that. So if we put a road across that, we are inevitably going to disrupt those natural flow paths. So look at where those streams are likely going to be after the road goes there. Well, we've stopped flow on the top side, or redirected flow on the top side, and then we're robbing flow on the low side. So all those red lines are spots where the streams were originally, and now they're not getting the flow they were previously, and well, that's obviously not good. Aside from just at the stream site themselves, so that what you're seeing can be interpolated in between those streams as well. So there's flow that's shallow groundwater flow and superficial flow that's being disrupted by the road. So the ditch inevitably acts as a dam and redirects that flow to points where the flow, instead of not getting as much as it used to, it becomes concentrated. So in this particular example, if we had no culverts in that prism, we would likely see flow concentrated at these 4 points. So they're highlighted in green there. So from left to right, at our switchback, well, we've got a high point in our road. The water hits that high point and back to the left and goes off the end of the switchback, whereas those 3 remaining points, they're low points on the road grade where the road would be overtopped with flow without some kind of crossing structure in place. So aside from robbing flow, if we look at, well, what kind of catchment areas are we dealing with at those 4 points? We can see, well, we're getting a lot. So those pink lines on top of the olive and violet color, those pink lines are the original catchment areas for those points, so on the undisturbed site. Now, if we have culverts, we can see, well, that point furthest to the left is getting that entire olive area adjacent to it. The next one over gets the violet, and then the olive and the violet. So those areas are much larger than the they're much larger than the original catchment area those points were collecting. And what that equates to is a whole lot more water flowing through those particular points. So we're increasing the volume, increasing the velocity, and increasing the energy. So that causes an issue downstream, where we can see issues related to scour, destabilizing slopes, etc. So usually to get around that, we add culverts. And here we've got the arrows indicating everywhere that we've placed our pipes. So in this case, we are mitigating the impact of concentrating that flow, but we aren't eliminating it. So here there's still a few spots highlighted in red where there originally was a stream being indicated, but we are still robbing it of flow. It just so happens that flow that the road's intercepting above, well, it ends up concentrating down below and would have otherwise created a channel there. So inevitably, as we're dealing with our roads, you're going to change the flow regime to some extent. It really is a matter of trying to minimize it. Now, adding culverts and ditches and whatnot is not the only tool in the toolbox. So if we look at this particular example, it is an awful place to put a road. So in red, we have a bunch of head scarps where there's previous open slope failures. So those failures happened without a road there. Then we've got a bunch of scoured channels, and then we've got a bunch of cones there as well. So needless to say, it is a very sensitive spot. And of course, one of the most important tools in the toolbox is well, considering the problem holistically and maybe deciding to put your road somewhere else. So that is by far the favorable solution here. And in this particular example, with the same constraints, we can get to the same destination without mucking around with that awful hillside. Not to say the example's easy, but it's certainly less gnarly than the other option.
Awesome. So that was kind of our introduction to the types of content we're going to be talking about today. When it comes to drainage design elements, we are really going to be focusing on, I'm going to say, 3 major ones. The first of which Matt just got to at the end of that example, which is the road's location itself. So the impact that that initial location selection has on your ability to have proper drainage. So we'll be looking at road location, then we're going to take a look at minor culverts and cross drains. And then finally, we're going to take a look at a few different elements that are controlled by the cross section. So that's ditches, and then we're going to include in that section one of the more advanced functions, which is an independent ditch profile. So we'll look at that workflow. We're going to include armoring, so with a rock spill apron, as well as discuss the road's shape. So that's the crown or the insloping or outsloping. There are a few advanced drainage functions that, just given the scope and time that we have available on webinars, we're not able to tackle today. But in preparation for this webinar, we really do realize the importance of including these as content in upcoming webinars. So please stay tuned. Once our spring web calendar comes out, I believe you're going to see major culverts, off-take ditches, as well as bridge abutment design included in that calendar. So that's kind of where we're going next in terms of the actual software workflow. So for our first topic, we're going to be taking a look at the hydrology tools inside of the terrain module, as well as a role that they can play in helping you with determining the road's location. So there's 5 hydrology tools, well, sort of. There's 4 plus an extra feature. We've got watersheds, drainage area, streams and ponds, and flow paths. And then the ability to have a feature become a hydro enforced feature, which basically means we can allow water to flow through it. So all of these tools, we're not going to go super in depth into each of them today. We're going to show you how to use them, but we're not going to go into a lot of depth. But if you're interested, we did put on a great webinar about 9 months ago when these tools first came out. It's up on our YouTube channel. We'll drop a link in the follow-up video, but you can check that out, Culverts and Hydrology Tools, and we go into much, much more depth. So with that, I'm going to pass the screen over to Matt, and we're going to go into the software and take a look at these hydrology tools as well as the role that they can play in the road's location.
All right. So we are going to start right from scratch. And aside from just the hydrology, or the tools that are earmarked as hydrology tools, there's a lot of other functionality that really does complement considering your drainage in your design. So for that, I'm going to start right from square one. We're going to open up terrain. And of course, if we want to see how we're interacting with the surrounding, and the pertinent spatial information is really is square one and an important step. So for this, I'm going to bring in my LiDAR data, and in this case, it's DEM data. We'll bring that in here. So, and when we selected that data, I made sure I've got enough data for the particular area that I want to deal with. So I'm not just looking at, well, the exact piece of ground that my road's going to sit on. I've got enough information to see the surrounding terrain and what I'm going to influence, interact, disrupt, etc. with that. So I've got my LiDAR data brought in. Another thing that we might want is some ortho imagery. So we could bring in off the live maps if we wanted to, or if we already had something that we wanted to use, we could just add it in as a background. Here I've got an image that I'd like to include as a background. And well, we may have other spatial information that we'd like, KML, shape, etc. Existing road here, I'm going to bring in the line work for that. Now, so far, we've just got spatial information. obviously we're going to want a surface to deal with. So I'm going to take this LiDAR data that we have. We're going to click generate, and we're going to generate our topo. Now here I'm going to sparse just because I'm going to use the 3D view a lot, but we'll click a button and it's going to do its thing. And think about it as it takes the series of points and turns them into a surface. So we have a surface that allows us to really leverage the 3D view. We can see what we're dealing with here. And for this, well, this project that we're looking at, a fictional project, is I want to go from this existing road out to a point out here. Now, with this, as we introduced, we're looking at something fairly hilly and irregular. But if you're dealing with more benign terrain, drainage is, well, often even more important there. One useful function in the 3D view is the ability to exaggerate your scale. Now I'm going to do this and turn it back because I don't really need it for this one, but we can exaggerate that scale and we can really see what the ground's doing. So more useful on really flat areas. Now, with this and kind of stepping into that hydrology tools functionality, I'm almost always going to want to consider what's there for streams and critical flow paths, ponding areas, etc. So with that, we're going to click hydrology tools. We're going to streams and ponds, and I'm going to run this. So our hydrology tools are a raster calculation. So it's based off of cell size, stream drainage area. We'll hit OK, and we'll wait a moment. And there we are. So we can see where we expect there to be streams. Now, for this, if we happen to know where we're probably going to have a major or significant crossing, well, I'll probably just run the drainage area calculation. So at this particular point, or at least somewhere handy to it, I'm probably going to cross the stream because my goal is to get here. I'm going to just run the drainage area calcs. I'm going to just use my current point. It's also going to give me my most hydraulically remote path and a centroid for the polygon. And there we are. And so with that, if I click this guy here, I can see, well, this drainage area is about 112 hectares. So that's our drainage area tool. Next, we have, well, in this particular example, we happen to be lucky. Our road is, well, on some undulating terrain, but there's a good chance we'll have the luxury of putting the road on a ridge. So for that, we can pretty easily just cruise around and see where the ridges are. But if we want to actually see the specific break, we can run the watershed tool. And there we are. So I can see these lines indicating where my different watersheds are. I can switch over to the plan view here as well if I want to see it graphically. So I can see, well, there's my existing road. I've got some watersheds up here that are kind of separating things. And I think I'm pretty well set in terrain. So with that, I've used the tools considering where I'm putting the road and setting myself up to succeed. I could totally run the path explorer to choose where to put the road, but I'm going to click it in by hand here. One, to talk about why I'm making consideration of making. Two, I want to intentionally put the road somewhere kind of silly. So we're going to save this. I'm just going to save this as topo. And then we are going to switch over to location. So I'm setting up a new design file. I'm just going to start with a single point. And now we'll talk about it more later. Now this is just a simple resource road, so I'm not going to use a full page structure here. I'm going to use this cross-section template, so I'm just going to assign that. And I'm going to click in my alignment. So I want to, and I think kind of a spot that's easy for folks to consider as a reasonable spot as well, just come off here and go to there. Let's do that. So we'll go right over here. Now, of course, the software's dynamic. It's going to me everything that I'm dealing with, and we happen to be quite lucky here where it just works. My max grade for this one is 14%, but I'm going to make a few adjustments. And well, here in particular, I want to cross that stream a little more perpendicularly. And we'll pull this back here, pull that down here. And let's run that along. So we've got a fairly straight shot from point A to point B, and a few curves. And I'm going to just generate a vertical here quickly as well. And here I could design the vertical the same way that I designed the horizontal, but I'm just going to optimize it.
And Matt definitely went fast through some of those dialog boxes. But again, today's goal is really about drainage, not how to design a road.
Yeah.
If you are interested in that, shoot us a note in the chat. Happy to send you some links to videos on those topics.
So I've got a vertical, and I'm going to just kind of zoom out here. And well, we can see we're scooting right across there to get to our destination. Now, I wouldn't plan on putting it there, provided that my design specs allowed me, because we're going across this colluvium slope and we're intercepting a bunch of flow. We can see in the watershed that's being delineated here, we're fairly low in it, right above a reasonably sized creek. So let's look at doing something different. So again, just starting from scratch, drawing something in by hand. So, and I'm gonna use my line work here as a bit of a guide. Again, I'm gonna just switch my templates. We're not really focusing on that now, but just switching it over for that apples to apples comparison. And we'll go up here, we'll go around there, and we'll zoom out a bit. And we can make an attempt to go that way, but as we zoom out, we can see things are getting pretty ridiculous. So we're kind of limited by grades here. Instead, we are going to have to cross the slope, but we're going to do it much higher. And it's going to be fairly benign terrain as well to do that, which is all good things. And we'll add in our curves. And we can run our vertical optimization here as well. And ultimately, where I'm going with this is, well, this one's a lot more attractive for me. And it happens, I've looked at it previously, we're on flatter terrain. It's not as straight of a road, but we're on flatter terrain to get there. It's cheaper, we're interfering with less stuff anyway too. So with our design time costing, just earthworks, this straight shot is almost 100,000, whereas this one that twists and turns, staying on the flatter terrain, which usually the ridges are flatter, gives us benefits from costs and the environmental impact. Now, all that being said, despite that being the clear superior option based off of what we're considering here, as we go forward, I'm going to consider this in the rest of the webinar, just because it's a little more interesting for stuff we're interacting with. With that, I'll pass it back to Erin.
Awesome, thanks, Matt. Okay, so now we're going to get into the design and workflows for actual drainage elements. So the first of which, we're going to take a look at culverts. So culverts, shown in the picture here, are cross drains that allow water to be moved from one side of the road to another. And when it comes to RoadEng, there's kind of two classes of culverts. There are major culverts, shown here on the page. So major culverts, or the one that you can kind of subtly see in the background is another example of one. These are much, much larger culverts where we're typically modeling the whole excavation for the culvert and its placement, calculating volumes, and spending a lot more detail in terms of its placement and design. These are done one culvert at a time. They better consider, stream profiles and crossing skew. So these are a type of culvert that we're actually not going to cover in today's webinar because the workflow is a little bit larger than what we're going to show you. So for today, we're going to be focusing on minor culverts, or those cross drains that you saw in the previous picture. These can be added to a design, road design, quite quickly and easily using the culvert editor panel inside of the location module. There's a bunch of different options for its structure type, as well as class, whether that's, say, a natural stream, for example. And you have an ability to add them one at a time or at intervals. Now, as Matt's going to show you, adding them individually at key places into your design is often really, I should say, the most useful. But in some situations, adding them at intervals can be appropriate as well. So we're now going to go back into the software and take a look at working with culverts and adding these to our design. And as Matt mentioned, I think he's going to focus on the worst road location choice, just because it's a little bit more interesting when it comes to talking about some of these drainage elements and the impact that they have. So with that, we're going back to Matt.
Alrighty. So yeah, it's of course covering hydrology stuff. It's you have to have interesting stuff to talk about, but really the best culvert is probably no culvert. If you can keep your road on a ridge and have the water naturally flow away from it, well that's preferred. But this lower option is certainly not the case. So we're going to add some pipes. Now, and again, just focusing on kind of the simple minor culverts and cross drains, we can go to our culvert panel. We can click add. And here we have the option to add in, well, choose the station. We can add in them at set intervals. So if you're doing like a multi-pipe crossing or venting your prism across an overlanding section, it's a useful tool there. But for these ones, I'm just going to have single pipes, and this particular location happens to be a natural channel. So I'm going to tick that box, and we can see our pipe is added. Now, with that, we have a few other things that we can muck around with. So here, my crossfall of my pipe is set to auto. If we wanted to have that perched, we could totally perch it. But in this case, I'm going to leave that matching my crossfall. We could also change our skew. So I've just changed that, and of course, it seems like every time I do it in the wrong direction. But I'll set it to be 80 there so we can match the alignment of our stream a bit better. And we can change our length or vertical position if we wanted to perch that pipe in the fill or embed it in cut. So we've added one culvert. If we want to change the size, we can double click it, put whatever diameter we'd like. We could change the structure type if we'd like here as well. And we can hit OK. We can see that updates for us. Now, that being a stream, we're going to assign an appropriate diameter here, but we'll move back here and we'll hit some interesting spots here. I'm going to just tweak this a bit to kind of make it interesting for later. And we'll drop that down a bit. So here I'm going to add another pipe. This one I'm not going to assign it as a natural channel. I'll just hit OK. And we can see there it tracks it separately for the name, so it's a cross drain. It also has a different default size being associated with it. So if I want to set up my default size, I could change that, and maybe we go with a 450. We hit apply, and then we could set save as default. So the next time we add a pipe, it's the diameter we'd like. Now, as we add in those pipes, we'll want to consider, well, how much flow is it getting? And we'll also want to consider, is there anything kind of suspended in that flow? So a lot of the time, these cross drains will want to bump up the size from just what it takes to cross or pass the flow, because there's going to be stuff suspended in that we don't want to block our culvert. Now I'm just going to turn on my terrain features here so I can see a little easier in the 3D view what I'm up against. I'm going to add a pipe here. I'm just going to do this fairly quickly. Another parameter that we have here, I've got a sump being added at my culvert location, which is great. And let's see. Sure, we'll add one there. One there. And we'll do one near the start of our road. I'm going to just bump that up a hair. Cool. So we've added in our culverts. And let's see here. I think I've got all the kind of the main talking points that I wanted to cover there. But for this, if I want to see kind of what I'm dealing with or how that road is going to interact with the surrounding terrain, so how my ditch is going to intercept flow and send that flow to my culverts, I can take this out of location. I'm just going to save this first as a location file. So I'm going to save my road design as a TRX file. I'm going to export out my culverts. I'm going to take my tin model. I'm going to view it in terrain first before I do anything else with it. Yeah, we're going to hit OK, and that's going to just open that up in another file here. So we've pulled that road out of location into terrain. Next, I'm going to go to my terrain file. I'm going to save this out as something new. And I'm going to just remove all these features just to start. But I'm going to click merge. I'm going to merge that road alignment in here. I'm going to remodel my surface with that road alignment in there, and I don't need to worry about my contours at this point.
I think it's worth mentioning this little workflow that Matt's showing you now. It is going to change dramatically as of version 12. So some really exciting changes happening for this specific workflow.
Yeah, and as we prepped and made that 3D view for the start, like we did that in version 12 because it's a lot easier. But yeah, we'll show how it's done in a little bit. So with that, we've merged our road in. We've got our culverts. I'm going to use those culverts to make them hydro-enforced features. So I'm just going to take those features, so, and what we call them, culvert bottom. So I've got all those culvert bottoms, and I'm going to click the wrong button apparently. Let's invert that back. I'm going to reverse them just so they're all pointed the right way. And I am going to make them hydro-enforced features. So that's going to allow the flow to move through our pipes. Now, next, I'm going to make a series of points. And we'll go there. Oh, and I would have almost forgot this guy here. So I've drawn those in. Now I'm going to take those hydrology tools, click drainage area, and I'm going to run the drainage area on all those locations. We'll hit OK. And there we are. So we can see, well, at that particular point, we have 112 hectares. So up a little bit, and that's just because we're catching a little bit of the flow from our road there. And well, 3.9 hectares. So we can see, one, how much flow we're getting at the particular culverts for having context when sizing them, but two, just to see, well, how much are we actually intercepting the flow beneath that, so we can get a pretty decent picture of what's going on. Now with that, I will hand it back to Erin here for a moment.
Perfect. So as we approach the time limits of our webinar, we've got a bunch more topics. So if you can, keep hanging out with us. Our next topic in terms of a drainage design element is ditching. So ditches, obviously crucial for directing the surface water away from the road, preventing water from pooling and causing damage to your surfacing or to your subgrade. So we're going to be looking at two different kinds of elements when it comes to ditches, which is first the simple ditches that are included in your cross-section. So these are an element that we build in our cross-section template. We're going to look at that one. And then we're going to take a look at the second example, which is having a ditch with an independent ditch grade. And ditches with an independent ditch profile really are more applicable, I should say, first and foremost, for areas of flatter topography. So if in this case, you can see in the road example here that there's a section of the road that's got a very, very small grade, 0.14%. So in that type of really flat design, the margin of error to build a ditch at that grade and to not have ponding is really small. So allowing us to have a ditch grade independent from your road grade can be really useful. It gives you that, again, precision control to make sure you've got effective drainage. So just a quick look at the two different alignments. So basically you have a road alignment, and then you can see here in highlighted in blue, this is the independent ditch grade, allowing water to be directed properly towards culverts. So we're going to take a look at ditches in the software. First, simple cross-section template control of ditches, and then we'll take a look at that independent profile.
Alrighty. Okay, so my template that I'm using, it has a ditch in it. So ditch parameters, we can open up templates, we can expand this thing, and we can come in here and we can change our parameters. So usually we'll want to be cognizant of capacity for starters. So having enough room in the ditch to carry the flow that we expect. May include adding a bottom width instead of just a V ditch like I've got here. So we can make those changes and see what it is we're dealing with. Now in this particular example, our ditch is intercepting flow coming off the hill. And that's the primary purpose for it. But ditches have other benefits too. So they can kind of be used as a linear borrow to help build up the road prism, which might add other benefits for snow removal or bearing capacity. So yeah, they're important. And from a not just drainage perspective, they can also be useful if you have a recoverable slope to give you somewhere to store surfacing material as you're grading your road, or have vehicles pull off and use them without having to worry about getting stuck. So simple ditches, easy. They're going to be right in the default templates that you're running with. If we want to go with something a little more elaborate, and again, as Aaron said, this one is usually more common on flatter terrain than kind of hilly stuff like we have here. But if we decided that we didn't want the ditch to follow our road grade, so at this point I've got a culvert here, I've got a culvert upslope of it. They're somewhat close together, and I'd probably leave them separated. But if we wanted to allow our ditch grade to take the water from here all the way ahead to that one, well, we could use an independent ditch grade for it. So with that, let's get rid of our culvert that was at that location, because we won't need it anymore. And we're going to create a new alignment, and we can use the ditch profile as that. So here I've got my ditch profile shown as a template code. So DIR is what I'm interested in. So we can go add horizontal. We're going to create the horizontal alignment from a point code in H1. And we're interested in DIR. Now, in this particular example, you can see we're running along with that. So I'm right out there. And let's, well, lop this thing off. So I'm gonna not worry about all the stuff outside of the area that I'm really interested in. And we're going to get rid of the stuff at the start there as well. And I don't want any points in between those two particular spots. I'm getting rid of my profile points. So we've got that set. I'm going to just shift this thing up. So from this guy here, I am going to go into my template, create a new template, and instead of having a fixed depth, I'm going to go onto the E library and I'm going to use a ditch with a vertical tie. Where are we at? Ditches. Copy. Paste as right. Now that looks kind of silly, doesn't it? So we're going to change this to match our defaults. We'll keep it as a V-ditch just for consistency. And the slope, we're going to go with a 2-to-1 slope. Now the big thing here though is our ditch depth, instead of being fixed, we're going to reference that vertical alignment that we just created in horizontal alignment 3. So we've got that. We're going to select it here, and we can see as we're going back here, well, it's going to follow the edit to get up over that hump that we're dealing with. Now, it doesn't change because we created the template. We just need to assign that particular template for that particular chunk of road. So 930 to 1086. And there we are. So much deeper ditch at that particular location. And we've got our independent ditch taken care of. So I'll hand it back to Erin.
Excellent. Oops, as I spastically clicked the wrong button to share it back to me. Hang on one second. Okay, so last topic when it comes to an in-software demo, we're going to be talking about the road's surface. So grade and the road shape have a huge impact as well on how the road's surface drainage performs. 3 sort of typical surface shapes. We've got in-sloped roads, out-sloped roads, and a crown. And I think the next slide, I'm just going to quickly flip to it, really demonstrates, again, why shape matters. So here we can see the results of improperly shaped roads. In all 3 of these cases, the water was not directed off the road surface, and that's resulted in rutting, potholes, and scouring. So what Matt's going to do next, he's obviously going to show us a little bit about how you can control the road's surface shape. And then if we have time, maybe he can show us a little bit of how we can visualize it back in terrain as well, using the example he's already moved there. So with that, we're going to head back to Matt, final topic in the software, which is going to be the road's shape.
So we're back in our design, and I did just get rid of that independent ditch because on this example I don't like it. But yeah, so our prism shape is obviously important. It's also, most of the control for that lives in the template editor. And I think by far the most common shape is going to be a crowned prism. So, and I'm going to just crank this up a little bit more to make it a little more prominent. So typical crown, we have flow going left, flow going right from the center of the road. Now that gets the water away from the road as quickly as possible. Stuff on the inside goes to the ditch. The stuff on the outside goes off your fill slope and down to wherever it was going to go. A lot of advantages to that, but there are some. I want to have an in-sloped or out-slope road. Now, one way to tackle this is you could come in here and you could just say, well, this whole road is, the upslope side is on the right, and I want to have an in-sloped road, so I'm going to make my left crown a positive value. I'm going to go back to the way I had that. Now, and that there's zero things wrong with that functionality. But if you have a road that's, well, going back and forth over ridges or switchbacking up and over a slope, keeping up to date with having that going on the right side or the other is a bit of a nuisance. So there is another roadway component that we can leverage. So we'll go with this resource 2, in slope, out slope. We're going to paste this in here. And here I'm going to use my parameters from the previous component. So I'm just going to paste my parameters in there. And I'm going to get rid of this guy. And this one I don't want to include the shoulder, so we'll get rid of that. Now this one, we see there's a parameter that's B out slope. I'm going to set that to 0. We can see it's tipped inside. When we copy and paste that to the left, we can see it's insloped. And if I put my road on a slope going the other way, it's automatically switching over for me. So to apply that, we'll hit OK, we'll hit OK, and we'll hit assign by range, and we'll apply that XX1. So the inslope template is, well, really a tool to help further ensure that your road's intercepting flow. So it could be that if there's sensitive terrain down below that you don't want to have any additional flow beyond where you plan to make that cross at a culvert or cross drain or cross ditch or dip, you can use that to help with it. Now, the other thing that is common here is if you have kind of a steep cut slope that you expect is going to ravel and infill your ditch, you can also act as a bit of a redundancy, where even if your ditch is filled up, there's still a little extra capacity to keep the water from going over the road edge and eliminating your shoulder. So that is an inslope. Now, an outslope is going to be basically the same but different. So we're going to just take this, copy and paste as left, and we'll come in here. We're going to turn that the outslope parameter off, and we'll do the same here. So with that, we're forcing well, we're not forcing it, we're allowing the water to cross the road, provided that there's no ditch. So usually if you're using an outslope template, you are not using a ditch. And here I'm going to set that ditch depth to 0 rather than eliminating the component, so I can still add a sump if I do want to use a culvert anywhere. Yeah, so if we want our road to look like that, just looking in the cross-section view, we can see that, well, water's going to come down here, go into your road cut, run across the road. So we'll hit OK. We'll hit assign by range, and we'll assign that. And there we are. Now I'm going to pass it back to Aaron here momentarily, and we're going to run through a couple more slides to discuss this. I guess maybe I'll.
Okay, let's go take a look at a couple slide examples. Yeah, of how this could work. And then perhaps in a future video, Matt, I know our timing is so tight, we can demonstrate how to create these arrows.
Yeah, totally. Yeah, so sorry for going so much over, but here we are. So yeah, we've got a couple visualizations to help articulate kind of why this isn't a silver bullet for things. So looking in the road cross section, it's kind of intuitive. Oh yeah, the water's going to go across the road. Great. It will on flat grades. So if you're on a flat grade, it's going to go perpendicular to your road across it. Flat grades are pretty uncommon, and even then they're undesirable, because they're oftentimes whatever you're using for your crown or out slope is kind of marginally yeah, it's not a very pronounced slope that gives you a lot of wiggle room if something gets muddled up. So with that, the out slope is kind of really susceptible to things like rutting, greater berms, etc. Because any imperfection in that road surface is going to, well, catch flow. And once that flow catches, it's going to well, scour, create more of a trench. You're going to get a washout, or you may get a washout, I should say. Now, the other thing that is even trickier about these is the concept works great on flat terrain, but when you're running with steep grades, so here we've got one that's at 17%, and I forget what I was using for the crossfall here, but assuming it was 4, well, in the cross section, it looks like water's going across the road, but if we look and add our slope vectors on that road surface, we can see flow's going to spend a lot longer than what we'd expect running down your road. So that is well, compounds the problem. Infection can catch things, and even if your road is a perfect shape, eventually once you get enough water and enough velocity with that, it's going to channelize over things anyway and self perpetuate the problem, where it's going to make ruts and wash things out. So yeah, and then if we go one more on those really flat surfaces, well, the flat surfaces oftentimes aren't graded perfectly, or you get soft spots where you get a little divot and people drive over it, pumps, and you get those potholes that everyone sees. So you'll notice the potholes are more common on the tops of hills than they're on the slopes in between them. So with that, we've got our road surface covered, and yeah, we could take that back over and look at how it interacts with the original topo surface, or the mechanics are the same. It's just the design perspective, the water is allowed to flow across the road rather than get trapped in the ditch and concentrated on those culvert locations.
Awesome. Thank you, Matt. And thank you everyone who has stayed with us an extra almost half an hour past our allotted time. We decided to take on an awful lot of content for this one, and we hope you found it really useful. Lots of other exciting webinars in the calendar. Be sure to check them out, softtree.com/webinars, as well those ones on major culverts, bridge abutments, and offtake ditches. We'll look to add those into the calendar as well. Yeah, in the near future. But thank you, everyone. Thanks for being with us for our first webinar of 2025, and looking forward to an awesome year of webinars ahead. So with that, have a wonderful rest of your day. Thanks, everybody.
Thanks, everyone.